section is on 6.4 and we're going to solve by separation of variables. So just like the way it says separation of variables, we're literally going to separate the two different variables that we're going to have in this. So this looks familiar. We have as dy over dx is equal to y minus 3x. And if you remember in 6.1, we actually took this right here, the dy over dx equals some kind of variables, and we made a chart. We made, in this case, an x and a y chart, and then also a slope chart, and we did slope field. We did the graphing of this. Okay, so now in this case, we're actually not going to graph it, we're going to solve it. So what we're going to do is we're going to go ahead and take this. Also right here, we're going to be given a condition. This is what we call a condition. And notice it's in parentheses. So we're going to have this is going to represent x and this is going to represent y. We'll substitute this in this case and actually find c in this one. Okay, so we'll walk you through this one. So the first step is to have dx by dy and dx is by itself. So I want to get rid of the denominator of dx. So I'm going to multiply both sides by dx right here, multiplied by dx on this side right here. So that's going to cancel out right there. And then we're going to have is then dy is equal to, and then right here is y minus 3x times dx. Okay, so since dx is on this side right here, we want to keep the x right there and get rid of the y. So since it's multiplication, we're going to go ahead and divide it out on both sides right there. So divide it out, so that becomes y minus 3 on this side right here. Okay, so then this cancels out. Then we have is 1 over y minus 3, right? dy is equal to, and then we have is x dx. Okay, so now we're going to take the integration on both sides right here. Integration on both sides right there. And then you're going to have to go through and ask yourself, is it something that's a simple integration? If it's not a simple integration, is it by u sub? If it's not u sub, is it tabular? If it's not tabular, it's going to be by parts. Or actually, it could be a formula. And then the formula always goes back to the derivative formulas that we've used in chapter 3. So in this case, this side right here is going to be a u sub, and this is going to be a simple integration right there. So let's do a u sub on the side right here. So I have this u then is equal to y minus 3. So y minus 3. du is equal to just dy right there. So then we have is the integration of 1 over u right there, du, is equal to the integration of x dx. Okay, so the integration of 1 over u we know that is going to be the ln right there of u, right, is equal to, and on this side right here is a simple integration, so it'll be x squared over 2. And then we're actually going to go ahead and put plus c right here. Now, I'm only going to put plus c over here, although I took the integration over here technically, and I should be putting plus c right here. I'm not going to put plus c here and here, because eventually what we're trying to do is solve for c. If I put it here, what I have to do is I'm going to bring it over onto the other side. The c's going to cancel each other out. That's why we only want c on one side, and let's just keep it on the right-hand side right here. Okay, so let's go ahead and substitute that u back in. So it's going to be ln of absolute value of y minus 3, right, is equal to x squared over 2 and then plus c. So now we're going to do the substitution. So we said back here that the conditions of 0 and 1, this represents the x, this represents the y. So let's literally substitute each of these values into here. So then I'm going to have is ln of y we said was 1 right there, so it's 1 minus 3 equals, and then x represents 0 right there, so it's going to be 0 basically, right? Because 0 squared is 0, divided by 2 is 0, so it's 0, okay? And then right here I'm going to simplify this. This is why ln is going to be an absolute value, because I can't have a negative y value, a negative number right here. So in this case, it's going to actually be a positive 2, right? So we're going to keep as ln a positive 2 right there is equal to c. So this is what c is. We eventually now found what c is right there. So we're going to take the c and we're going to substitute it back into this equation and finish our algebra. So I'm going to put it actually back in here, right here, just because that's where my y comes in right there. So in this case, I'm going to split this up now and get it as ln of y minus 3 is equal to, and then we have is x squared over 2, and then my substitution of this ln of 2. So since it's a positive ln, so we're going to go ln of 2 right there. That's c. All of this right here is c, and that's what I substituted as this part right there. Okay? Now we're going to have to just do the algebra. So the algebra is just basically getting y by itself. So we want to continue on, and we want to bring this ln over here over to the other side of the equal sign. So we know that the property of ln, when we bring it over to the other side of the equal sign, it turns into an e. So we have then as the absolute value of y minus 3 is equal to e, right? And then if this becomes e, everything on this side right here gets pushed up as an exponent. So then we have as x squared over 2 plus, right, ln of 2. And then we also learned in Algebra 2 and also in pre-calculus, one of the properties of e is that if you expand this right here, since it's a plus, it's a multiplication, right? And if it's a minus, then it's a division. So in this case, I'm going to go ahead and split it up. And the reason why I want to split it up is actually it's going to simplify this further. So it's going to turn into times e ln of 2 right there. And then this is still the absolute value of y minus 3 right there. Okay, so this right here is the reason, because I'm going to cancel this out, because remember one of the properties of e and ln, it actually cancels itself out. This 2 comes down from becoming an exponent and actually just becomes a big coefficient of 2, and then we still have is this e x squared over 2 right there, and then I still have is this y minus 3. But I'm going to take off that absolute value because I want to continue on and solve for y. Do the algebra part of it. So we just have one more step, which is then bringing that 3 over on the other side of the equal sign, and we're going to bring it over by adding it. So we have is 2e x squared over 2 and then plus 3, and that's your final equation. So we're trying to figure out what that final equation is, and in previous sections we always had concluded as plus c. But we actually found what c was in this case, and we substituted it back in, and it came out to this as my final answer right there. Okay, let's try another problem, and let's go a little bit more challenging problem here. So what I have then is dy over dx is equal to x times y, and then the whole quantity squared, and then the condition of 1 and 1 right here. Okay, now to simplify this, because again eventually what we want to do is we want to separate the x and the y. I'm going to distribute this 2 into each part right there, and we're going to get as x squared right there and then y squared right there, and we'll just keep it as dy over dx right there. Now I can only do this because this is a multiplication, right? If there was a plus or a minus in between the x and the y, you can't actually distribute to each one of these guys right here. You would have to go ahead and distribute by doing the double parentheses, binomial parentheses, right? And then do the foiling and then work it out there. Okay, but in this case, because it's multiplication, this is legal. We can actually distribute to each of those powers right there. Okay, so then let's go ahead and multiply by dx on both sides. So then I have as dy is equal to x squared, y squared, and then dx on this side right here. We want the x by itself with the dx right there, so we have to get rid of y squared. So we're going to divide both sides by y squared right there, and that leaves me y squared right there. Okay, so I just put a little 1 right there. Okay, so let's go ahead and simplify that. So I have as y squared, 1 over y squared dy is equal to x squared dx. Okay, now let's go ahead and take the integration of both sides. So again, when I'm taking the integration, I ask myself, is this a simple integration? If I can't do simple, can I do a u-sub? If I can't do u-sub, can I do tabular? If I can't do tabular, can I do by parts or by formula? Okay, in this case, actually, this becomes a simple. I can actually bring this up right here, the y squared right there. So this is going to become something like this, negative 2, right? dy is equal to the integration of x squared dx. Okay, so then if I take this integration, it becomes, if I add 1, I'm going to have as y minus 1, right, divided by negative 1 on this side right here. And then on this side right here, a simple integration, so it'll be to the third divided by 3 and then plus c. Okay, so now let's go ahead and substitute in the conditions that were given to us in the beginning, that 1, 1, and substitute into this part right here. So the y negative 1, this, if I simplified it, it actually comes down from becoming that there. So I'm just going to go ahead and put this down here, right? So it's like this right here, algebra 2 right there, right? Because if I bring it down, it becomes positive right there. I want to do this so I can see this better, and I'm sure this is going to help some of us right here. So I have then as 1 over negative 1 right here, because that's the substitution for the 1 right there, okay? Then I have is equal to 1/3, right? Because 1 cubed is just going to give us 1, plus c right there. So we're going to have to bring that 1/3 over to the other side right there. This is -1 minus 1/3, right, is equal to c. So this is going to become basically 3/3. So we have as -4/3 is equal to c. So that's what c is equal to right there. So we take the c now and we substitute it back into the equation. So where do I put it? Let's put it right here. Let's just put it right there, because then that kind of helps us out for the separation right there. Okay, so we're going to go ahead and take that right there, put it in there. I'm going to keep that 1 negative down there. All right, so then is equal to x to the 3rd divided by 3, and then again that -4/3 is what c is. Okay, so since we already have the common denominator of 3, let's make this into one fraction. So I'm going to have is then 1/-y is equal to x to the 3rd minus 4/3 is the common denominator. Now we like this format right here. We've also learned in Algebra 1. We could probably cross multiply, do it proportionally, but here's an easier step. We can literally take this and do a flip. We just do the reciprocal of this, but as long as you do it on both sides of the equal sign, still that Algebra 1 rule, then it's okay. So I'm going to flip this over, literally. So I'm going to flip this over like this so you can see this, and then this becomes 3/x cubed minus 4 like that. Do you see that? So as long as you flip it and do the reciprocal of this right here, right, and the other side as well, then that's legal. So we want y that's positive by itself on this side, so we're going to bring that -1 over to the other side by multiplying it. And so then we have y is equal to -3/x cubed minus 4, and that becomes your final answer in this case right there. Okay? All right, let's go ahead and try to do the work now.